Okay. Can you hear me okay and see my screen? Yes, no? Thumbs up from, okay, thank you, Joe. I saw you. Cool. So we're going to talk about our Boolean logic today. And the cool thing is I know a lot of you have already explored this and played with Boolean logic from your project check-ins yesterday. And so know this also, that yes, we're gonna have you like struggle with the concept before we actually teach it, because remember, doing that, contemplating a project helps pave the way for those neural pathways, so that when you actually learn the thing or the concept, your mind just sticks to it and you learn it better, and it just helps make those neural connections. So there is a method to the madness. So we're going to talk today about our Boolean logic. We're going to talk about truthy and falsy in Ruby, which may be new sounding terms for some of us. We're going to learn about the logical operators of and, or, and not, and explore how to combine these that will help us with some flow control and if statement kind of logic. So what I'd like you to do for a warm-up, I'll drop this in your chat. You're going to spend about 4 minutes in this warm-up. The first minute, I want you to just do a quick Google search on what is truthy and falsy in Ruby. And then for the next, oops, I didn't do that, format that correctly in your channel. That should be okay. But then I'll have you drop into a prize session and play with a couple of these values to see what they evaluate to. So go ahead and spend about 4 minutes doing that. Okay, so let's talk about that warm-up really quick. And I would love to hear what you found out in the Google search about what does truthy and falsy mean, and what is it in Ruby specifically. If anyone wants to raise their hand to share out what they found on that topic, we would love to hear from you. I know you all are so calm and relaxed right now after meditation. Yeah, Sandra, thank you.
Mostly that like falsy is either false or nil. Not Phil, I don't know what I was about to say. But false or nil, and then like truthy is everything else.
Yeah, so in Ruby, we have, thank you so much, Sandra, that's perfect. So in Ruby, we have two falsy values, two and only two, and they are false, as in the Boolean false, and nil. Okay, everything else evaluates to truthy. And what do we mean by this, like truthy and falsy? Well, we're drawing a distinction between the actual Boolean values of true and false, because those are, you know, like a hard true, a hard false. But everything else in Ruby can evaluate to either being something that is truthy or falsy. And this can be helpful for, well, it's what like if statements are looking for. If you think about how we write an if statement, right? And I'm just in an MD file, but if we do like if, you know, a string equals a string, right? Your if statement to determine whether it should go down that branch of logic is going to look at this statement and say, does this evaluate to not to true, but does it evaluate to truthy? Or does it evaluate to falsy, right? And so if we just did something like this, actually, let's make a guess. That's one. Else, I'm going to put this in my, let's actually put this in a Ruby file. That makes much more sense. Make a guess in your head. Oh, will this work? Maybe it'll work. Okay, make a guess in your head on if 1 will print out or 2 will print out. So make that assumption in your head, and then I'm going to run this and we'll see. Hopefully I can actually run this code. Okay, let's run this and see what we get. It put, so we can see right here, I didn't need to pry, it puts 1. Okay, so it went down this branch of logic. Is that what you guessed? You don't have to actually answer that question, but like in your head. So you want to get in the habit of making those assumptions of what do I think my code is going to do, and then test your assumption and either then confirm the knowledge or fix the knowledge that for the guess that you made. And so why did it go down this branch of logic? I didn't do any kind of comparison here to get like a true or false value. Yeah, Ben?
It's because like the inherent value of a string is going to be truthy, I think. Is that right?
Yes, right. And so remember, and this is where it can get kind of funky, but where it can get also really cool, is that remember everything in Ruby evaluates to something, to either a truthy or a falsy. A string is still going to evaluate. In a string, because it's not false or nil, is going to evaluate to truthy. And our if statement here is just looking for this statement to be truthy, not true. Okay, so that's some knowledge for you to kind of like store away. We'll definitely see that later today, and you'll probably definitely see it in your projects. Is that a, I mean, I'm going to use probably definitely today. So now when you did this warm up and you were using, you know, these test values to check this condition, and this is exactly what you were building on here, right? This if statement, what does this evaluate to, truthy or falsy? Did any of these surprise you or kind of take you aback and you'd be like, oh, I didn't expect that to work? I like that better. No one was surprised. You're all pros. Cool. Let's try this though. I'm just giving you a hard time. So I'm going to run this again with this one, because this one to me was very surprising in the beginning. So I just want to go over it. But here, all I'm evaluating is an empty string, right? So is that going to go down the I'm truthy or the I'm falsy path? There's nothing in that string. It's just quotation marks. So I'm going to run my file, and you have a guess in your head of what it's going to, if it's going to print I'm truthy or I'm falsy. And it's truthy. Awesome. I see some people nodding their heads. So good. I think hopefully it's coming together a little bit. So even an empty string will evaluate to truthy, because remember, and I'm going to say this only a million times today during the lesson, okay? So the only two values that evaluate to falsy in Ruby are false and nil. Okay? And I'm going to keep repeating this because especially if you have a background with other languages have different values that will evaluate to truthy and falsy. Okay, so in Ruby specifically, it's false and nil is what evaluates here. Okay, and now we're going to shift a little bit and talk about Boolean logic. So here, let me give you some more real estate here. So our Boolean logic and the Boolean operators. This is so low in my screen. I'm going to just put stuff down here so that my screen's not right. So this is mid-screen. So we've got a couple different logical operators, and I know that some of you have played with these before in your Battleship project. So the one of them that we have is called the AND operator. Okay, and that's what that is saying is if this thing is true and this other thing is true, or actually I should say truthy, right, is truthy, then the whole statement should be true. Okay, and so what does that look like? So we can say like, if 1 is 1 and, so this is our Boolean operator of and 2 equals 2, then we already know that this statement is true and this statement is true. And so then this logical operator is looking at both sides and saying, okay, if both sides are true, then this statement will evaluate to true. And we can see this if we drop into a pry session too. So if we go into pry, we can see 1 and 1 and 2 is 2, and the whole thing is true. If we throw it off a little bit 2 should not equal 3, right? So this side should evaluate to true. This side should evaluate to false, which would make this whole statement false, okay? Because the and operator is looking for both sides of the statement to be true. So we'll write this. Returns true when both sides of the statement are true. That's the best talking and typing at the same time I've ever done. I'm glad this is recorded. Just kidding. Okay. Any questions about the or? Oh, sorry. Any questions about the and operator? And don't worry, you're going to get some practice with this. Okay. So actually what I'm going to do next is there's 2 more. There's an or and there's a not operator. But I'm going to have you explore those in what's called a truth table. So what is a truth table? This is kind of like a grid, a mathematical grid thing, where we can say, okay, if we have 2 variables, like if one is A, the other is B, and depending on if A is, let's say, if A is true and B is true, then if we evaluate the logical operators, so if we do if A and B, oops, then what will that evaluate to? Well, that's the one we just looked at, right? So if A is true and B is true, then this statement should evaluate to true. Oh my gosh, can't type today. Right, but how about the or operator? And how about the not operator? Okay, and then we can go down the list and say, okay, well, if A is true and B is false, what will this evaluate to? What will this one evaluate to? What will this one evaluate to? So it's like a grid. Does that kind of make sense with what a truth table is? I think once you get some practice with it, it'll make some sense, because we're going to go into just a quick breakout room to complete this truth table with your group, just to start getting familiar with it, because we're going to build on its complexity throughout this session. And so what I'll have you do is, you know what, I'll leave it up to your group if you want to either screen share, have someone screen share, or if you want to each work on it and fill it out and then just compare your truth table evaluations. And we'll spend just about 5 minutes in this one. Okay, so I dropped the truth table in so that you could copy paste it into a text editor into your Slack channel. So I'm going to put you in the breakout rooms for about 5 minutes to complete the truth table and just go over how does the or work, how does the not work. Okay, any questions about what you're doing in your breakout rooms? Okay. Oops, 1 second here. Okay, rooms are open. Back. So let's go ahead and finish filling out this truth table. Actually, to fill out this one, so these 2 pipes, this is our or operator, right? And does anyone want to come off mute, volunteer to explain, like, how does the or operator work? When does the or operator evaluate to true? V?
Whenever one of the statements is true.
Yes, so this one returns true when one side of the statement is true. Awesome. Yeah, great job. So then V, what would be then well, this is kind of a silly one, right? If A is true and B is true, what would A or B evaluate to?
True.
True. Actually, V, do you want to just go down this list with me on the or operator?
Sure.
Right, so for example, if A is true and B is false, what will the or operator evaluate to?
True.
Awesome, true. And then if we flip them, does it make a difference?
No.
No. So that one's also going to be true. And then if both are false, it would evaluate to
False.
awesome. Yes. And maybe this seems a little trivial right now with doing it with these two variables, but we have to make sure we're super clear on all these basics before we start building in complexity, because we're kind of going to go from like 1 to 10 really fast. So I just want to make sure this is really clear and you understand how to use a truth table. And V, I was talking to everyone. I was not talking to you there. So,
Yeah.
okay. And then how about, will someone walk through the rest of the and operators with me? If someone want to raise their hand. Yeah, Ben, go ahead.
So when A is 1 and B is 0,
Or when A
A
is
and-
true and B is
oh yeah, sorry, I just kind of defaulted to the, yeah. So if A is true and B is false,
Mhm.
A and B is false.
right, because here we're looking for both sides to be true. Awesome. And it doesn't matter if we flip them?
Nope.
Yeah. Okay, goodness, I wish I was in an Excel sheet right now. And then if they're both false, what will it evaluate to?
It'll be false.
Yeah, awesome. Cool. Thanks so much, Ben. And so awesome. And then if I can get someone else, someone different, to raise their hand and tell me how this not operator works. What is that one doing? That one's just a little bit different. Aiden, yeah, thank you.
Hey, so it's just looking at A, and it's just flipping the value of A.
Mm-hmm.
Oh, so what it means is just the opposite. So it's saying not truthy or not falsy.
Mm-hmm. So it will switch the truthy, falsy evaluation. Oh my gosh. Whatever. That's supposed to say evaluation. I can't think and spell right now. We'll switch the truthy evaluation of the statement or variable that it precedes, so that it's in front of. Cool. So for example, if A is true, Aiden, what will not A or bang A be?
False.
Yeah. Awesome. And so we're just going to do whatever the opposite of this is, right?
False.
False. So then if A is true, then bang A is
True.
yes. And now I can't remember if I've said true or false. It's all jumbling in my head now. So that's fun. Cool. Thank you so much, Aiden. I appreciate it. Awesome. So, so this is the basics that we're going to like build off of, right? Because sometimes you do use these a lot in code. To like evaluate two statements, because you need to know, like, if this is true and this is true, then go down this branch of logic. But if this is true and this other thing is not true and this other thing is not true, then we want to do something totally different. So these Boolean operators can really help us with that. Let's consider this statement. Actually, let me just put it my pry. What if we did this? What if we had, will this go? Okay. False and true or true. So think into your head. And when I say think to in your head, I just mean like think to yourself, and you can test it in pry. Ooh, actually don't test it in pry. I want you to think about it and actually just make an assumption first. What will this statement evaluate to? And if you have no idea, you have a 50-50 shot at the guess, right? I'm just kidding though. I want you to guess with some kind of logic. So let's see. Cool, so it evaluates to true. Will that evaluate to true if we flip it? True or true and false. Will that still evaluate to true? What if I change that? I think it will. You know, it's so funny that some of the hardest things to do is to force true false values when you're trying to force true false values. How about this one? What will this one evaluate to? False. So some of these I think might be a little trivial, but what this is actually not evaluating from left to right. So I know Mike alluded to this the other day in one of his lessons, but we have a precedence table, which means Ruby's going to evaluate these Boolean statements in a very specific order. And so this is the precedence table. It's supposed to be code. Here, why don't I also drop this in your Slack channel so you have it? My backticks are not working today, so oh well. So this is the order that Ruby is going to evaluate a Boolean logic statement or any kind of comparison. Now there's some operators in here that you might not be familiar with that we definitely have not gone over. We're not going to go over those at this time. I just want you to see that there are other operators out there than the ones that we've gone over. So we can see this bang, the not operator is the first thing to get evaluated. And the and the or are not on the same level. Right? So and operators get evaluated before an or operator gets evaluated. Okay? And then the assignment operator down here, and then these are our other comparison operators. Okay, so if we have something like, let's do this example. So if we have something like this, okay, how will this get evaluated? Like, let's kind of take it step by step in Ruby. Does someone who hasn't raised their hand yet want to raise their hand and walk through this with me based off of the precedence table and kind of walk through the order it goes through? I normally just call on people, just so you know, but today I just feel like getting participants. So I feel like it's Friday. It is Friday, but I don't know what that means. Anyways, Adam, go ahead. So Adam, which piece is going to evaluate first?
Yeah, so the and is going to evaluate first because all we have is an and or an or.
Yeah, and so the and's going to look at this little statement right here, right? It's little tiny container. So then what will this evaluate to, this little piece?
False.
Yeah, because both sides are not true. So then we can rewrite this as saying false. This becomes false, and then we have a true. Okay, Adam, now what gets evaluated next?
Nothing. It's just, you can look at either of these, and if any are false, it's false. They're
Well,
all ors, so.
Well, but the or operator only needs one side to be true in order for it to evaluate to true.
Sorry.
No, that's okay. That was good instinct for the and operator. So when we have something that's all on the same precedent level, then what Ruby does is reads left to right. Okay, so since the ors are all the same, it's on the same level of precedence, so we can read this from left to right. So this piece will evaluate first. So this will become false or true. And then Adam, what will this evaluate to?
True.
Awesome.
I have a question on this though.
Yeah, please.
I understand that it reads left to right, but if you go to line 67 and you just see as a shortcut, okay, there's ands and ors, there's a true after an or, this is going to be true no matter what. Like you don't necessarily have to go left to right or do anything. Is that right?
I wouldn't trust that I wouldn't trust that one. If you have something where it's all and statements, it's easier to see because an and statement, everything needs to be true. But with the ors, I feel like there's it adds some complexity. What I would say anytime with code is make an assumption, but then test it. Yeah, cool. Sam, question?
Is this precedence table kind of universal for anything even outside of Ruby, like PEMDAS kind of?
I don't know, to be honest with you. I'm sure other languages might go off different precedences.
Okay.
You know what? I don't know. It depends how they wrote it. That's a great question, though. Cool. So the next one I want to consider is, hold on, is this one. Okay, and I'm going to have each of you just take a minute and maybe write this one out and go through the steps, kind of like we did here, to break it down, like what happens first, then what does the statement look like, what happens next, and then in a minute, I'll have someone volunteer to go through it with me.
Hey, Kat, do you mind scrolling a little bit up so I can see the other way around, so I can see the precedence? Because I'm not. Yeah. Thank you.
Yeah, thank you. Okay, do I have a volunteer, maybe someone who hasn't gone yet, who wants to walk through how this would evaluate? Oh, Mike, yeah, thank you.
Hey, so
Hey,
in parentheses goes first. So that
yes.
would be true. And then following the precedence table, the and comes before the or.
Wait, let me rewrite it. So you're totally right. So when we see parentheses, that kind of, it's just like, remember we learned in math, maybe we learned in math, the PEDMAS thing, whatever the acronym was, the P was parentheses and that's always first. So what did this evaluate to, Mike?
True.
Yes, to true.
So,
Okay.
and then just following the precedence table, the and is going to be evaluated first on the left side of the or. So that would be true, pipes, and then false. And then since we have a true on the left side, that will be true as well.
Yeah.
So
Awesome.
in total, it'll all be true.
Yeah. Perfect. Yes. Thank you. Oh, Adam, I think I see more clearly what you were talking about before, where if you have the pipe and but you see that one side of the pipe evaluates to true, then the whole thing should be true, right? Is that what you were saying?
Yeah.
Yeah. Okay, cool. Yes. I think then that is a valid shortcut that you can consider. So great job. Sorry, I totally didn't understand what you were saying before.
That's okay.
Trues and falses all day long today, friends. Sam, did you have a question or were you?
Yeah, I had a question. If you have two cases of parentheses, let's say in the situation, the one parenthesis case was true and false, and the other parenthesis case afterwards would be true or false, or false. Now would it go left to right because they're both in parentheses, or will it still like matter which one in the parentheses is an and, which one is an or?
Good question. So can we write that out again? So if you said it feels like true and false, and then like an or, like this? Or tell me what you're thinking.
Or, and then another parenthesis case of true or false. And here in the precedence, it would say like an and case you would evaluate first. And yeah, it's in the left anyways, but let's say like the or case is first. Would it, because it's in parentheses, wrap, would you go left to right? Or would it be based on what's inside the parentheses?
Yeah, good question. So you're, like if it was like this, basically.
Yeah, perfect.
Yeah, so that's a great question. So each parenthesis, yes, it will go left to right, and each parenthesis like set will evaluate first. So like this one will evaluate to true, and then we'll drop down these pipes. And then this set here evaluates to false. So then this whole thing would be true.
Cool, thank you.
Yeah, absolutely. Okay, cool. Let's take a 5-minute palm and then we'll come back and explore some more complex situations. Okay, did any questions Or did you think of any questions or other scenarios over the POM? Yeah, Grayson?
So this is slightly off topic, but is there a way to overload one of your objects so that it will evaluate specifically to truthy or falsy?
What do you mean?
So if I have a class and I want that class to be falsy if a certain condition is met, is there a way to implement that without adding a special method to use in that case?
I'm not sure. I know that I follow exactly what you're trying to do, to make like a whole class truth evaluate to falsy, or like any object that's instantiated from it.
Yeah.
Well, I mean, the only things that are ever going to evaluate to falsy are nil and false. So there wouldn't be a way. Can you override that? I don't know. And I don't know that you would want to, because
Okay.
you wouldn't want to go against like the conventional knowledge of Ruby. So if I'm not following your question completely, I apologize, but maybe if there's a specific example, we could look at it.
Okay. Yeah, I might put something more detailed in the parking lot later.
Yeah, that would be awesome. Cool, cool.
Okay.
All right, cool. So let's go into our breakout rooms. What you're going to do now is very similar to the first one. There's a Google spreadsheet for your truth table, so that'll make the Excel spreadsheet a little bit easier. You should be able to make a copy of that on your own Google Drive so that you can work with it. Slightly more complicated examples, so definitely use Pry and use your groups to work through these. Okay. All right, your rooms are open. I'm going to move it down here. Yeah, Liam, thank you. Let's go for it.
No problem. So I guess the first thing you would look at is that parentheses within a parentheses, the A and B.
Yeah.
And that would be false and true, so that would be false.
Cool. So, and I'm going to do this a little bit painstakingly step by step here, just so we can see it. So I did hear this is what you just told me to do, that evaluation of A and B, and I'm going to switch the A and B's to their actual values.
Cool.
So we got false, and then this is just and the true, bringing down the pipes, and then I'll bring this down. What is B here? Oh, B's true.
True and true, since it's not false.
Yeah, exactly. We have that bang, the not false. So cool. So what would you like to evaluate next?
Just do the one on the left, and false and true, which is false.
Awesome.
And then true and true is true. So then it's just false or true, which is true.
Awesome. Yeah, perfect. Right. So if we just use that precedence table and break it apart and do little tiny steps at a time, thank you so much for that, Liam. That was perfect. Then we can really simplify these very complex Boolean statements. So awesome. Cool. Did any other questions come up in your breakout rooms about this, about that truth table from any groups, or anything interesting that you want to share? Okay, let's look at one more thing, because you're probably thinking A's and B's and C's are really cool, but how does this really help me like with my code, right? And so what we can use these Boolean logic statements to do is to help us with some flow control, especially if we've got something where we have nested if statements. A lot of times we can unnest these nested if statements by using Boolean logic instead. And why would we want to do that? Well, nested if statements are very slow. They take a lot of processing power. And so we want to avoid nested if statements if possible. So one thing we can do, like for example here, this is not a fully built out class, so I'm hoping you can make some, like infer some, you know, the code that's not here. But we know in Ruby, our convention, right? If we have a method that ends in a question mark, it's going to return a true or a false. So we can work off of that one. So, or that knowledge. So we can see here that we've got a branch of logic. If the animal is a cat, it's going to put I'm a cat. But then if, depending on if it's a cat, we want it to do either with fur or without fur. So on one hand, I do like that, you know, we're breaking up the cat into one flow of logic and then telling it to branch and do something else, but that nested if statement is not ideal. So what we can do here is we can combine some of this. So this one I can see it'll go down if it's a cat and it has fur, then it's going to say I'm a cat with fur. So we can pop this one, this logic right here, we can pop it up here with an and operator, right? So what this says is if this animal's a cat and it has fur, then we want it to say, I am a cat with fur, like this. Okay, and then we could actually get rid of this. But now we still haven't, what about the case where it's a cat but with no fur? Which is that really a cat? Debatable. But for the sake of this method, I guess it is. So here, now we can utilize an else if, because else if we can also give a condition to. And we're going to say we still want it to be a cat, but now we want it without fur. Right? So it'll evaluate and say, okay, if this is not, it'll say if this is true, but then that bang operator will flip it. If it's an animal, if it's a cat but has no fur, then we can utilize this and say without fur. So now I'm a cat without fur, else I'm not a cat. So we did add a little bit of complexity here in the conditionals that the ifs evaluating, but we unnested the if statement, which we would prefer to have a single, a one-dimension if statement rather than a nested if statement. And so that's where this Boolean logic can help us. And so this, I know a lot of you have been experimenting with this in your battleship projects, but definitely look at, you know, if you can get rid of an if statement just by having some Boolean logic, right? Because sometimes you can actually get rid of a whole if statement too. Any questions or thoughts on this piece, on this right here? How we like flatten that out?
So is that more efficient to run as well, Kat, for the computer?
Yes, if it's an unnested if statement. Nested if statements are very non-performant. They take, because it'll go down like the if statement, both ifs, it'll go down all branches of logic to evaluate. So it's not efficient to do nested if statements, particularly in Ruby. It's just not very performant in that way. So we want to unnest those. Plus, if I'm, in terms of readability, here, let's bring that other one back. This was what the method was, like this. I think it's debatable on which one is more readable, to be honest. Well, no, I'm gonna take that back. I would think anything that's unnested to me is more readable, because then I don't have to keep in my mind what branch of logic am I in, right? Especially if I had like a third nested, if it's a fur, if like animal, oh gosh, I can't spell, animal dot speaks, right? And if we keep going down this branching logic, it gets more and more unreadable. So if you've got nested if statements, see if you can go and figure out a way to bring that up into a non-nested if statement using some Boolean operators. Awesome, good question. Cool. Other questions about any of the Boolean logic, about using Boolean logic to simplify nested if statements? There is a repo in the lesson plan to practice some of this. I was gonna say you could, yeah, I would rather you spend that time practicing in your project, to be honest. Like if you have nested if statements in your project currently, especially I'm thinking of valid placement, that method. is a great place to start utilizing some Boolean logic to see if you can unnest if statements, if you can even take out if statements, right? Because here's the thing too, and I've said this to a couple of my groups, if you have an if statement that's only returning true or false, like instead of this was just returning true, or this was just returning false, usually in those cases, you can get rid of the if statement altogether using Boolean logic. Okay, and I want to note one thing to note too here is this will evaluate to true or false. So I don't need this, right? This is redundant at that point because if this evaluates to true, yes, this will be true, it'll still work, but it's unnecessary. So if we just have a method that ends in a question mark, you don't need to do a comparison operator. Sydney, question, go ahead.
Yeah, so is there a way that like, so for example, if I have an or statement, but on both sides of the or, like maybe only the first two things are different, like I need this to be true and then this to be true, but then everything that follows after that, it needs to be true for both things on that side, on both sides of the operator, if that makes sense. I'm probably confusing myself and confusing it. Like I only need one thing, the first things to be or, and then the end is for the, like they both have the same ands going down after that. Like I feel like I have some repetition because it's just that first thing that is kind of sends it down its journey. It's like, but I'm having to repeat because it's on, I need to say like this whole side needs to be true or this whole side needs to be true. But like the majority of that true side is redundant. It's repeating for both sides. Does that make sense?
Yeah, and I wonder if you could like take the part that's repeating and encapsulate that in its own helper method, and then just call on that helper method to kind of clear some of the redundancy or the repetition, if that makes sense. Sometimes too, like I think what you're doing is good though, like writing it all out and then noticing like, oh, the left side of these two statements is exactly the same. So maybe I could just stick that in another method that says like, I don't know, check a specific thing with a question mark, and then you could just call on that. So you can definitely encapsulate these kinds of things in helper methods too.
Okay, yeah, yeah.
Okay, if that wasn't too clear, we can always look at specific code later too.
No, it just like a light bulb went off. So I was
oh,
like,
good. Love when that happens. Isabel, question?
I think that in a way kind of answered mine. I was wondering if we were in this exact example, if we were to remove these as an if and else if statements, I get that we could put an or in here, but is there a way that we could write this to where it wouldn't be just one long line saying like, if this or this, if that makes sense?
Maybe like you're evaluating more than two things.
Yeah, like if we, so like you said how we could take if statements and turn them into not if statements and turn them into actually just Boolean logic. So if we did that for that example.
This would just become this.
Okay.
Well.
Yeah, no, I see that. I see that.
Well, and this doesn't actually work exactly with like, so maybe this method needs to change to like cat. Well, I already have a cat. Well, animal dot. So this one's really only looking at if this is a cat and it has fur, right? So maybe this method's called like fluffy cat, right? And so then if either of these is false, this whole statement, this whole method now will return false. So sometimes it takes some finagling sometimes to get this to like work properly. Order will matter, right? If you're going down, if you have these in an if statement, the order will matter because if it finds one it's true, then it's absolutely not going to go to the next else if to evaluate. So sometimes the order is going to matter, and that can throw off how you like structure it. So I know that's kind of not clear. I think it's hard when we don't have the code in front of us to really like pull it apart and see. Definitely a good thing to experiment with. And I apologize, I don't have a more direct answer for you.
No, I think creating helper methods was my answer because I was just basically saying like, how do I make not a super long thing? And I think it's just creating helper methods.
Love it. Helper methods are great. All right, cool. So I want you to have a little bit of a break before your cohort norm starts. So Joe, let's get your question and then we'll close up.
Can the bang operator only be used in front of a method that returns true or false?
Great question. No. Here's, if we drop into a pry session, right? Remember, everything like evaluates to truth and falsy, right? So if we have, like, say we have a variable, I'm just going to say A is a string of hello, right? If we put not A, what does everyone think? What's going to happen? What will happen when I hit return?
Is it, yeah.
Right? So because what that bang operator is doing, it's kind of forcing a Boolean value. And so what this is doing, so hello, right? Everything in Ruby evaluates to something. A is going to evaluate to hello, which is truthy. Okay. And so what that bang operator does is flips its truthiness and will turn it into a Boolean. So that then does become false. So
could you do a question mark just for real quick and see what, okay.
So Joe, to answer your question, you do not have to put A in front of a Boolean. It can go, I'm sorry, a bang in front of a Boolean. It can go in front of anything. Good question.
Sorry, what would it do exactly? Was it just, I mean, if like in this context,
like why would you do that?
I feel like that's something I have to play around with to kind of look at each method by method.
Yeah, a lot of times you're going to use that for maybe like an if statement where you need to know maybe something could return nil, right? And then so if your variable, like maybe it's animal.exists, maybe this returns either an animal object or nil, right? If that's what the return value of this method is, then sometimes we can use a bang operator to say like, okay, if this is returning nil, flip that to a truthy value and then go down this branch of logic. Puts like, I don't exist, right? Because if animal.exists evaluates to nil, then, but I want it to go down this branch of logic to make the if statement go down, I have to flip the nil because nil would evaluate to falsy. I could flip it to true and then it would go down this branch of logic. I saw Ben's mind explode. So cool. Okay, that was a really great question, Joe. I'm really glad you asked that. So, all right, I'm going to close this up though, so you do get another break. If you have more questions, put them in the thread. If I didn't make a thread or if a thread was not made, I will go check on that right now. So cool. Thank you so much. I will see you all soon.
Thanks, Kat.